Hi everyone, welcome to the presentation of our paper WavePaint, Resource Efficient Token Mixer for Self-Supervised Inpainting. My fellow co-authors are Darshan Sampat Kumar and Professor Amit Sethi, and we are from the Indian Institute of Technology, Bombay, India. Inpainting. Inpainting is the computation task of filling in the missing parts of an image. It's a generative task, and currently most of the state-of-the-art models are transformer based, which are really computationally heavy, and most of them requires a adversarial training as in a GAN or diffusion training. This is our architecture WavePaint. The core part of the architecture is the WaveMix block as shown here. The WaveMix block is a token mixing architecture which uses 2D discrete wavelet transform for token mixing. It is a parameter-free operation which makes the model parameter efficient. It also reduces the feature size, which makes the computation much more efficient while consuming less GPU. And WaveMix has been shown to perform well in tasks like image classification, semantic segmentation, and image super resolution. We also use a depth-wise convolution block for extra token mixing. For this architecture, we give the input image or the masked image along with the mask. So it's a mask-aware image inpainting architecture, and we use transpose convolution to resize the image back to the original size in the decoder. For training, we don't use a GAN or a diffusion loss. We only use L1, L2, and LPIPS loss. Because the entire image is downsampled, especially in the first layer, the resolution is reduced by half, and inside the WaveMix block also the processing is further in a reduced resolution. Most of the computation is very efficient. The token mixing from wavelet transform and depth-wise convolution actually aids the model to learn the features required to fill the image. So these are the quantitative results of our architecture compared to the previous models. So we choose architectures which are like less than 100 million parameters to compare, and among them Llama is like the best performing model, and we are showing that we are outperforming Llama in narrow mask, medium mask, and wide masks in painting. You can also see that our model is like having very less parameters compared to the previous model, and it is also giving state-of-the-art results in FID metric in all the three masks category. And it will also work well with the wide masks or the large masks. We also in our experiment observed mask generalization where models trained on wide masks can perform well in medium and narrow masks. So this is the result in Celibe HQ 256 by 256 images, and this is for 512 by 512 images where we are still getting state-of-the-art performance. Since Llama was giving the best performance among all the models, we compare WavePaint in terms of efficiency with Llama. We see that WavePaint has much lesser number of parameters, and it outperforms Llama in terms of image quality, that is in painting quality, and it consumes like half the GPU only, and it is like 3 times faster in training and in inference. These are some of the qualitative results of wide masks in painting using WavePaint. In celeb faces, we can see that the model is able to inpaint the facial details very well. Even in imaginary data set, in different kinds of masks, the model is able to inpaint the features properly. And compared to Llama, like many of the artifacts that occur in inpainted faces are removed using WavePaint. In conclusion, we see that 2D discrete wavelet transform can be used for token mixing for image inpainting. The performance is on par with the previous larger models, and also we do not need adversarial or diffusion training. Our model consumes less GPU memory, and it is much parameter efficient and faster. Thank you.